Hello guys, welcome on Tesla Eduventures. In this video today, we are going to discuss the NSEP 2023 paper, code 61. Okay, and I have attached the answer key of this paper in the last part of the video. You can directly scroll to the end and you can see the answer key. Okay, so now let us start from the question number 1. You can see that in this question there are two balls which are projected from a cliff, which is a building. One ball is projected with a speed of u at an angle of theta above the horizontal, and other one is projected in the downward direction at an angle of theta. We have to find out the difference of their range on the ground. We know that range of first one will be u cos theta into time t1, and range of second one will be u cos theta into time t2. So the difference of the range will be u cos theta into t2 minus t1. And we know that the value of t2 minus t1 is 2uy by g. Okay, so delta r will be equal to u cos theta into 2uy by g. So delta r will be equal to u square sine 2 theta by g. So this is the value of the difference of their range. So the correct answer is C. Now let's move on the next question. In this question, you can see that there is a solid block of mass 3 kg. It is suspended from the bottom of a 5 kg block with the help of a rope. This rope has a mass of 2 kg, and when this system is being pulled with a force F in the upward direction, then the whole system experiences an upward acceleration of 2.19 meters per second square. So we have to choose the correct option. So first of all, let us find out the force F. So F, the complete system has a mass of 10 kg, and therefore 100 Newton force would be acting in the downward direction, and F minus 100 will be equal to 10A. A is 2.19, so F will be equal to 100 plus 21.9, so it would be 121.9 approximately. So this is wrong, and the net force on rope. So net force on rope will be MA, and M of the rope is 2 and A of the rope is 2.19. So this is also wrong. And the tension at the midpoint. So we are writing the equation of the part of the rope and the block 3 kg below this point. So T minus the total mass of this system would be 4 kg. So T minus 40 will be equal to 4A. A is 2.19. T is equal to 40 plus 8.7. So T is approximately 48 Newton. So correct answer is B. Now if we use the value of G as 9.8, then it would be exactly 48 Newton. Okay. Now we move on the next question. In this question, you can see that there are two ropes which are connected to this block of mass 0.4 kg, and this system is rotating about this center with a time period of 1.2 seconds. The length of these two ropes is 1 meter and 1 meter, and this length is 0.8 meter, and therefore this would be 0.6 meter. Okay. Now we have to find out the values of these tensions T1 and T2. So we can say that the first equation is the fact that, let's suppose this angle is theta and this angle is theta. So tan theta is equal to 0.8 upon 0.6, which is 4 by 3. So theta is equal to 53 degree. and therefore we can say that T1 sine theta will be balancing out T2 sine theta plus mg. Okay, so T1 minus T2 sine 53 will be equal to mg, which is 4, and sine 53 is equal to 4 by 5. So T1 minus T2 is equal to 5. Okay, and the value of T1 cos theta plus T2 cos theta. So the value of T1 cos theta plus T2 cos theta is equal to mr omega square. So T1 plus T2 into cos 53. So cos 53 will be equal to 3 by 5, and it would be equal to m, which is 0.4, r is 0.6, and omega square. Now omega will be equal to 2 pi by t. T is 1.2. So this is 20 pi by 12. So it is 10 pi by 6, or we can say that it is 5 pi by 3. So this is 5 pi by 3. Okay, so this is T1 plus T2. So if you will solve these equations, then the correct answer will be C. Now let's move on the next question. In this question, you can see that there is a particle of mass m which moves in a straight line under the influence of a certain force such that the power delivered by that force remains constant. If that particle is starting from rest and it is moving on a straight line, then we have to find out the distance traveled by that particle in time t. So we can see that power is equal to F dot V, or the value of cos theta is obviously 1 because they are moving in the same, F and V are in the same direction. So this power is equal to F, where we can write down F as m dV by dt into V, and V dV is equal to P by m dt. Integrating both the sides, we can use the limit as 0 to V and 0 to T. This is V square by 2, and it is P by m into T, and V is equal to 2pt by m root, and V is ds by dt, and it is equal to under root 2pt by m. So ds is equal to under root 2p by m into root t dt. Limit of s would be from 0 to s and 0 to t. So s will be equal to under root 2p by m, and the integration of this would be 2 by 3 t to the power 3 by 2, and limit of time would be from 0 to t. So s will be equal to under root of 2p by m into 2 by 3 and t to the power 3 by 2. So it can be written as under root of, this is 4 into 2, 8 by 9 p by m, and this is t cube. So 8 pt cube by 9m. So the correct answer is D. Okay, now we move on the next question. In this question, you can see that there is a bullet which is fired from the surface of Earth, and it is given a velocity which is equal to the half of the escape speed from the surface of the Earth. We have to find out the maximum altitude reached by this bullet from the surface of Earth. So we can see that we know that the escape velocity is under root 2 gm by r, and ve by 2 will be equal to under root of gm by 2r, and the kinetic energy which we have given to it is half m v square is gm by 2r. So the kinetic energy is gmm by 4r. Okay, now we can see that the potential energy u initially on the surface of earth is minus gmm by r, and finally the kinetic energy is 0, and the potential energy finally will be minus of gmm by r plus h. So we can equate both the energies. So minus of gmm by r plus gmm by 4r is equal to minus of gmm by r plus h. Okay. So you can see that it is 1 by 4 minus 1. So you can write it down as minus of 3 by 4 gmm by r, and it is minus gmm by r plus h, cancelling gmm and negative sign. So you can see that 3r plus h is equal to 4r, and h is equal to r by 3. So the correct answer is A. Now we move on the next question. In this question, you can see that this is a cylindrical can and it is a hollow cylinder of radius r and height h. Its ends are sealed with 2 discs, and the complete hollow cylinder with the 2 cap is formed by the metal of same material, and its density is sigma. This is areal mass density, mass per unit area. We have to find out the moment of inertia of this closed can about the axis of symmetry, this one. So we know that the moment of inertia would be the sum of moment of inertia of these 2 discs, and it would be twice of m1 r square by 2, as well as the moment of inertia of the hollow cylinder, which is m2 r square. Now the value of m1 is equal to sigma into pi r square, and the value of m2 is equal to 2 pi r h into sigma. Okay, so I will be equal to sigma pi r to the power 4 plus 2 pi r cube h sigma. So we can take sigma pi r cube common, and it would be r plus 2h. So the correct answer would be C. Now we move on the next question. In this question you can see that there is a particle of mass small m. It is placed on a horizontal frictionless table, and it is rotating on that table with the help of a string which is connected to these masses 2m. Let us suppose that it is m0, complete mass is m0, or we can also use as 2m, and this is a single rope which is passing through this hole from the center of the table. So if one of the mass is gently removed, then we have to find out the new radius of circle of this small m mass. So we can say that the tension is playing a role of centripetal force for this mass, and therefore it would be balancing m into r omega square. Okay, and now this is r radius, and now we have this tension is balancing 2m g. Okay, now if we remove a mass gently, then the new tension m r dash omega dash square will be balancing mg. Okay, but we should remember that as this tension is acting on this mass and it is passing through the center of circle, therefore the torque of this tension about the center is 0, and therefore angular momentum of this mass is balanced, conserved. So the angular momentum initially will be I1 omega 1, and finally it would be I2 omega 2. Okay, or initially it was m r square omega, and finally it is m r dash square omega dash. Okay, so what we can do, we have to find out the value of new radius. So we can just replace the value of omega dash as r square omega by r dash square. And we can substitute this value here. So dividing these two, r upon r dash into omega square by omega dash square is equal to 2, and r upon r dash into now omega square upon omega dash square will be equal to r dash to the power 4 upon r to the power 4. Okay, so this is r dash to the power 4 upon r to the power 4, and it is 2. So this is r dash cube upon r cube is equal to 2, and therefore r dash will be equal to 2 to the power 1 by 3 into r. Okay, so we can see that the correct answer would be option number B, and obviously angular momentum is conserved, but the radius would be changed by the factor of 2 to the power 1 by 3. Now we move on the next problem. In this question, you can see that there are 3 stars of equal mass m, and they are rotating in a circle about their common center of mass in such a way such that they are equidistant from each other, which means that they are making a triangle if we are joining them with straight lines. Then you can see that the radius is given as r, and let us suppose the side of the triangle is a. So we can say that a by root 3 is equal to r, and a is equal to root 3r by the properties of triangle, and therefore the mass, this m, attracts this mass towards this side like that. This is the force acting by this mass on this mass, and the force acting on this mass due to the other mass is this, and these two forces are combinedly balancing out the centrifugal force mr omega square. Okay, this angle is 30 and this angle is 30, so 2f cos 30 is equal to mr omega square, and this is 2, f is g m square by a square, and cos 30 is root 3 by 2 is equal to m r omega square. Okay, where m is any one mass, so this is m. Now cancelling this 2 with 2 and this m with m, this is root 3 g m by a square is equal to r omega square, and omega is equal to under root of root 3 gm by a square into r. Now the value of a is root 3r, so omega is equal to under root of gm by root 3 r cube. So the correct answer would be option number D. Now let's move on the next question. In this question, you can see that the density of a liquid is rho at the surface and the bulk modulus is beta. Now we have to find out the increase in the density of the liquid at a depth of h due to the pressure of the liquid. And also we have to assume that rho is very greater than delta rho, which means that this change in density with depth is negligible as compared to the original density at the surface. And it also means that we know that the stress is dP and stress upon strain is dV by V is equal to minus of bulk modulus, and dP is equal to minus of bulk modulus into dV by V. We know that volume is inversely proportional to density, therefore dV by V is equal to minus d rho by rho, and therefore dP is equal to plus bulk modulus into d rho by rho. Okay, so now dP will be rho gh and divided by this bulk modulus, and it is d rho by rho, and therefore d rho will be equal to rho square gh by bulk modulus. So the correct answer will be option A. Now we move on the next question. In this question you can see that water is flowing at a velocity of 1.2 meters per second through a pipe of diameter 1.59 centimeters. We have to find out the time required to fill a cylinder of radius 2 meter and height of 1.25 meters. So we can easily check it out that the rate of flow of volume Q is area into velocity. Area of the pipe is pi d square by 4 and velocity is v. This is Q. Now we know that Q is dV by dt, and V volume will be equal to pi d square V by 4 into T. This volume is the volume of cylinder which has to be filled, and it is pi r square into h, and this is equal to pi d square V by 4. Cancelling this pi with pi, so this time will be equal to 4 r square h by d square V. So we know that capital R is 1.25 meter. In fact, capital R is 2 meter, height is 1.25 meter, the diameter of the pipe is 1.59 centimeter, which is 10 to the power minus 2 meters, and velocity is 1.2 meter per second. So by substituting these values in this term, we can see that the time period would be option A, which is 18.3 hours. Now we move on the next question. Into F, and F2 when they will cross, then it would be V minus VO upon V plus Vs into F. So the change in frequency delta F would be, F is common, V plus VO which is 348 plus observer is struck 20 upon 348 minus 30 and minus V is 348 minus VO, observer is truck, this is 20 upon 348 plus 30 into F. So it would be approximately 232 Hertz. F is 800. So we can see that we have subtracted the initial frequency with the final frequency, and it is positive, which means that final frequency is less than the initial one. So we can say that the frequency decreases nearly by 232 Hertz. So the correct answer is B. Now we move on the next question. In this question, you can see that there is a rope of mass m which is hanging from roof and its length is L. We have to find out the time in which a transverse pulse would reach to its top. So let us suppose that at this point, which is at a height of x from the bottom of the rope, the tension at this point would be m by L into x into g, because we know that the tension at this point would be balancing the mg of rope which is below this point. So this is the tension at this point, and m by L is mu, so T is mu xg, and V at this point will be under root T by mu, so V will be equal to under root of xg, and we can write down V as dx by dt. So dt will be equal to dx upon under root xg, integrating both the sides 0 to t, and this is 0 to L. So t is equal to 2 under root x by g, and integrating limits are from 0 to L, so t will be equal to 2 under root L by g. So the correct answer will be option number B. Now we move on the next question. In this question, you can see that there is a smooth tunnel AB whose length is 2L, and this tunnel is inside the earth, and the mass of the earth is m and the radius is r. A small ball is being released from this point, and we have to find out the time taken by the ball to reach end B. We have already done the derivation of the time period of this SHM inside the tunnel, and we know that the time period was 2 pi under root of r by g, and this is the time in which ball will go from A to B and then again to B to A. And obviously we have to find out the time of A to B, so it would be T by 2. So the correct answer would be pi under root r by g. So the correct answer would be A. Now we move on the next question. In this question, you can see that in a room, when a speaker S1 was switched on, then the intensity at a point P is 80 decibel, which means 80 is equal to 10 log I by I naught base 10. So I is equal to 10 to the power 8 I naught. You can see that. Okay, and when the speaker S2 was switched on, then the intensity at same point was 85. So this 85 is equal to 10 log I2. Let's suppose this is I1 and I2 by I naught, and I2 by I naught will be equal to 10 to the power 8.5. So I2 will be equal to 10 to the power 8.5 I naught, and when both speakers are switched on simultaneously, then I1 plus I2 will be equal to 10 to the power 8 I naught in 1 plus 10 to the power 1 by 2. So root 10 is approximately 3.16, so it would be equal to 4.16 into 10 to the power 8 I naught. Okay, so we can find out the resultant intensity as 10 log 4.16 into 10 to the power 8, and I naught is cancelled out, and you can further simplify it. 10 log 4.16 into yeah, and we have to add these two, so it is 8. Okay, so you can see that it is 10 log 4.16 plus 80, and this is approximately 6.2 decibels. So the resultant intensity will be 86.2 decibels. So the correct answer is option number B. Now we move on the next question. In this question you can see that there is a block of mass 0.5 kg which is moving on a frictionless surface, and it strikes this plate which is a massless plate, and it is moving with the speed of 2 meters per second. It collides with this pan and sticks to it, and the pan is connected to the spring which is initially relaxed. The spring constant is 32. So we have to find out the equation of displacement of the block after the collision. So we know that the maximum, see, at this position the net force acting on the block is 0, which means that this is the equilibrium position, and hence we can say that the maximum amplitude would be the maximum displacement of the spring. So half k x square will be equal to half mv square, cancelling this, and x square will be equal to m by k v square and x square will be m is 1 by 2, k is 32 and v is 2, so it would be 4. So x is equal to 1 by 4. Now you can see that omega will be equal to under root of k by m, and hence omega will be under root of k, which is 32, and m is 1 by 2, so omega will be equal to 8, and it is passing through the mean position towards plus a, and therefore the equation would be of sine, which is sinusoidal. So answer is B. Now we move on the next question. In this question we have to identify the wave function which is not representing a traveling wave. We know that any function can represent the traveling wave if it satisfies the relation of minus of v dy by dx is equal to dy by dt. Okay, and v is the velocity of the wave, which is omega by k, and omega is the multiple of time in this equation, and k is the multiple of x. So we can see that we can directly see that this is a equation of a traveling wave. This is also a equation of traveling wave, and among C and D, if we would satisfy this relation, then C would not satisfy this relation. Hence we can say that C is not the equation of a traveling wave. So the correct answer is C. Now we move on the next question. In this question you can see that there are two Carnot engines which are connected in series in such a way such that the sink of the first engine is the heat source of the second engine. So let us suppose that this is source of first engine, which is at a temperature of T1. This is engine 1, and this is sink of the first engine, which is at the temperature of T2, and this is engine 2, and the sink of this would be at the temperature T3. So they are connected in series. The efficiency of first one, neta 1, will be 1 minus T sink by T source, and the efficiency of second one would be 1 minus T sink by T source. We have to find out the efficiency of the total system. So first of all, let us see that T2 by T1 is equal to 1 minus neta 1, and T3 by T2 is equal to 1 minus neta 2. Okay, so multiplying these two, so T3 by T1 is equal to 1 minus neta 1 into 1 minus neta 2. So it is equal to, you can see that it is uh, let's suppose 1 minus neta 1 neta 2 and minus neta 1 plus neta 2. Okay, this is the value of T3 by T1. Now the combined efficiency would be 1 minus T3 by T1. So this would be equal to neta 1 plus neta 2 minus neta 1 neta 2. So the correct answer would be option C. Okay, now we move on the next question. In this question, you can see that there is a air bubble of radius 2 mm which is at a depth of 12 meter below the surface of water, and at that point the temperature of water is 8 degrees Celsius. That bubble rises to the surface where the temperature of water is 16 degrees Celsius, and if we neglect the effect of surface tension, then we have to find out the radius of bubble at the surface. So first of all, we know that the temperature is changing, and therefore we cannot say that it is a isothermal process. In fact, what we'll do, we'll equate the number of moles, which is we can say that P1 V1 by T1 will be equal to P2 V2 by T2. And P1 at the depth of 12 meter below the water surface would be P0 plus 12 rho g, and volume of that bubble would be 4 by 3 pi r cube. I'm just taking the radius because I would cancel the r. In fact, I would cancel 4 by 3 pi. So this is r cube. R cube is 8 into 10 raised to power. This is 1 mm is 10 to the power minus 3 meters cube. And in fact, 1 mm is 10 to the power minus 3 meter. And if we are doing r cube, then this is minus 9. Or we just have to find out in mm. So let us keep it in mm. And therefore P1 V1 by T1, T1 would be 8 degrees Celsius, which means we have to convert it into the Kelvin scale. So 8 degrees Celsius would be equal to 281 Kelvin, 281 Kelvin. And it would be equal to the pressure at the surface, which would be P0 into r cube, which is the radius which we have to find out, and divided by the temperature. The temperature on that surface would be equal to 289. 16 degrees Celsius is 289 Kelvin. Okay, so you can see that this P0 is 10 to the power 5 plus this is 12 into 10 into 10 to the power 3, okay, into 8 into 289 divided by P0 into 281. P0 is again 10 to the power 5, and this is equal to r cube. So r would be approximately 2.61 mm. So the correct answer would be option B. Now we move on to the next question. 4t by a into VA. VA is 4 by 3 pi a cube, and I'm cancelling out 4 by 3 pi. So it would be a cube only, plus PB would be PA plus 4t by B into B cube, and PC would be PA plus 4t by C into C cube. So you can see that PA into A cube plus B cube minus C cube is equal to 4t is common, C square minus A square minus B square. So T will be equal to PA by 4 C square minus A square minus B square into A cube plus B cube minus C cube. So the correct answer will be option, I can see that it is option number A. You can take minus common and you can see that option A would be the correct answer. Now we move on the next question. In this question you can see that there are two soap bubbles of radii A and B which coalesce to form a single bubble of radii C under the isothermal conditions. Now if the external pressure is PA and surface tension is T, then we have to find out the value of surface tension. So under isothermal conditions we can write down PA VA plus PB VB is equal to PC VC and PA will be equal to P capital A plus. In this question you can see that there are two organ pipes. One organ pipe is open-ended and it is of length of 30 centimeters, and the other organ pipe is closed-ended and it is of length of 23 centimeters. Both are having equal diameter and they are in resonance with each other in such a way such that they both are vibrating in their first overtone with the frequency of 1100 Hertz. So we have to find out the estimated velocity of sound in air. So you can see that there is a statement written that both have equal diameter. It means that we have to take the end corrections, because we know that the end correction of the organ pipe are equal to 0.6 times of the radius of the organ pipe. So this statement clearly indicates that we have to consider the end correction. So for open organ pipe, we know that for open organ pipe all the harmonics are there, and the first overtone in the open organ pipe will be V by L, which is 30 plus 2E, because end correction would be on the both ends of the organ pipe, and the first overtone in the closed organ pipe would be third harmonic, which is 3V by 4, and L is 23 plus E. Now as we know that end correction only occurs on the open end of the organ pipe, and obviously closed organ pipe has only one open end. Therefore we can say that the end correction would be only E. So cancelling this V with V, we can see that this is 92 plus 4E is equal to 90 plus 6E. So you can see 2E is equal to 2 and E is equal to 1. So now if E is 1, then V by 30 plus 2E is 1100. So V by 30 plus 2 is 1100, and this length should be in meters. So V will be equal to 32 into 11. This is 32 into 11, and this is in meters per second. So it would be 252 meters per second. Now we move on the next question. In this question you can see that this is a bar which is lagged in terms of the area of cross section, which means that as we will move from this end X to Y, its area of cross section will continuously decrease. So this end is maintained at a temperature of 100 degrees Celsius, while this end is maintained at a temperature of 0 degrees Celsius. We have to choose the correct option for the temperature with X. X is the distance from this end to this end. Now let us see that the resistance of this bar at any cross section, let's suppose there is a cross section of width dx. So the resistance of this cross section of this length would be equal to 1 by K, where K is the thermal conductivity, dx upon the area. Let's suppose area at this cross section is A. So dr by dx is equal to 1 upon Ka. And you can see that as we are going in the forward direction, A is decreasing, so dr by dx is increasing. So dr by dx increases with distance. Let's suppose that this is x, increases with x. And we know that the temperature gradient dt by dt would be equal to I into dr, where dt is the temperature difference across these two ends, and obviously dt would be negative because as we are moving ahead, temperature is decreasing. So minus dt will be equal to I, where I is the heat current, and heat current is constant for this bar, so this is I. So it would be equal to I dr, and dr would be equal to dx upon Ka, and dt by dx will be equal to minus I by Ka. I is constant, and as we are progressing in the forward direction, area is decreasing, therefore dt by dx would be increasing. So we can say that on moving in the forward direction, the temperature gradient dt by dx is negative, and therefore and it is decreasing. In fact, it is increasing because area is decreasing. Because area is decreasing in moving in the forward direction, and therefore the magnitude of dt by dx would be increasing. So the correct answer would be second, B option. Now we move on the next question. And at this point of time, the volume of gas is, let's suppose, V. So V is the initial volume, and V is equal to P by nRT. In fact, V is equal to nRT by P. This is the volume V at this point of time. Now gas is being expanded ice at constant pressure to attain back its initial temperature. So if P is constant, then we know that V1 upon T1 is equal to V2 upon T2, and V upon the temperature at this point of time is T by 4, and this is V2 upon the temperature finally is T, so V2 is equal to 4V. Okay, so this is the volume, and in this process the pressure is equal to P by 4. Okay, so the work done, obviously we know that the work done in process A is 0 because volume is constant. So the work done is only in process B, in which pressure is constant, and the process B in which pressure is constant, the work done would be P delta V, and P here is P by 4 and delta V is 3V, because V was initially V and finally it is 4V. So the work done will be equal to 3 by 4 PV, and PV is equal to nRT. So this is 3 by 4 nRT. So the correct answer is B. Now let us move on the next question. In this question, we can see that there is an ideal gas which has n moles, and initially the gas was at pressure P and temperature T. It is cooled isochorically to a pressure P by 4. So again, the gas after cooling is expanded at constant pressure so that it attains back the original temperature. We have to find out the work done in the entire process. So the first process is process A, in which we have cooled the gas isochorically, which means that volume is constant. And the final pressure is P by 4. So P1 by T1 is equal to P2 by T2. And obviously P is P, initial temperature is T, and final pressure is P by 4, and temperature is T dash. So T dash will be equal to T by 4. Now the gas is being expanded at constant pressure. So at this point of time the pressure of the gas is P by 4. So it is expanded back. In this question you can see that assuming Sun to be a perfectly spherical body of radius Rs and thus temperature of the Sun as T, we have to find out the total radiation power received by the Earth at a distance r from the Sun. So we know that if Sun is a spherical body, and obviously we know that Sun is an ideal black body, so power emitted by the Sun will be sigma EA T to the power 4, and for ideal black body E is 1, so it is sigma area of Sun is 4 pi Rs square into T to the power 4, and the intensity received on the Earth will be power upon 4 pi r square, where this small r is the distance between Earth and Sun. So I will be equal to sigma into Rs square T to the power 4 upon r square. And obviously we can see that the energy received, the power received by the Earth will be almost parallel due to the fact that Sun and Earth are situated at a distance of many light years. So conceptually we can assume that light would be parallel when incident on the Earth, and therefore the power received by the Earth would be intensity into the area perpendicular to the radiations. So the area perpendicular to the radiation is pi Re square, where Re is the radius of the Earth, and we can assume that if Earth was two-dimensional, then the area in which it would be receiving the power would be pi Re square. So the power received by the Earth would be sigma Rs square T to the power 4 upon r square into pi Re square. So the correct answer is option A. Now we move on the next question. In this question, you can see that there are 5 point charges, and Q1 and Q2 is unknown. Now the distance between each of them is 10 centimeter, and the net force on 2, 1 and 2 microcoulomb is 0. So we have to find out the value of Q1 and Q2. First of all, let us see that on 1 microcoulomb, 2 microcoulomb would apply a force in this direction, and this 2 microcoulomb would apply the same force in opposite direction. Therefore, the net force of 2 microcoulomb and 2 microcoulomb on this 1 microcoulomb would be 0. And therefore, the net force of Q1 and Q2 should also be 0, because it should remain in equilibrium, which means that Q1 and Q2 have same sign as well as their magnitude is same. So we can conclude that Q1 is equal to Q2 because as 1 microcoulomb is in equilibrium. Okay, so now let us find out the net force on any charge from 2 microcoulomb. So let us suppose that we are finding on the force on this 2 microcoulomb. So on this 2 microcoulomb, a force F1 would be due to this Q1, and a force F2. Now we can easily assume that if this is F1, then the distance between this 2 and this Q is thrice 30. So we can easily say that if distance is thrice, then the force will be F1 by 9, because the force is inversely proportional to the square of distance. So distance has become thrice, so force will become 1/9. and therefore we can say that the force on 2 microcoulomb, F on 2 microcoulomb is 0. So F1 plus F1 upon 9 plus the force on 2 due to 1 would be K into this K into 2 into 1 into 10 raised to power minus 12 divided by 20 into 10 raised to power minus 2 whole square plus force on 2 due to this 2 will be, this is 10, 10, 10, 10, 40. So the force would be K into 2 into 2 into 10 raised to power minus 12 divided by 40 into 10 raised to power minus 2 whole square. The value of F1 in this case would be equal to K into 2 into Q1 into 10 raised to power minus 6 divided by R square, which is 10 into 10 raised to power minus 2 whole square. So now if we will equate this complete force acting on the 2 microcoulomb to 0, then we would be getting the value of Q1 and Q2 equal to negative. Obviously they would be negative because you can see that these two terms will go on that side and the value of Q1 and Q2 would be negative, and it would be 27 by 80 microcoulomb. So the correct answer would be A. Now we move on the next question. In this question, you can see that there is a pulley and there are two blocks of equal mass M and M. There is a rider which can be considered as a ring or a disc which is placed on top of this mass M, and the mass of this rider is small m. What is happening in this question, that initially you can see that these two will go down and there is a ring which would stop the rider and it would allow this mass to pass through it. So when these two will cross this ring, then only the capital M mass block would cross the ring and rider would remain on the ring. And then this block is taking a time t to descend down by a distance of d. Okay, so we can see that obviously the acceleration initially is equal to m plus m minus m into g divided by 2m plus m. So acceleration is mg by 2m plus m. This is the initial acceleration when this rider is placed on the block. And the velocity of this block and rider when they would reach this ring would be v, and v would be equal to 0. In fact, v square would be equal to 0 plus 2as. Now a is mg upon 2m plus m into s. S is equal to h. So this is the velocity. So v is equal to under root of 2 mg h upon 2m plus m. This is v. Now we can see that beyond this point, beyond this ring, the acceleration would become 0 because these masses are equal. So this block or this system would keep on moving with the constant acceleration, in fact constant velocity. So the velocity v would remain constant throughout this distance, and d, distance, would be equal to velocity into time. So d is equal to, or we can say that d square is equal to v square, which is 2mg h divided by 2m plus m and into t square. Now we need to find out g. So small g would be equal to d square into 2m plus m divided by 2m h. So you can see, and this is t square also. So you can see that the correct option would be option A. Okay, so the correct answer is A. Now we move on the next question. In this question, you can see that there is a very small electric dipole of dipole moment P that exists on the x-axis, and its dipole moment is also directed towards x-axis. There is a non-uniform electric field which is directed towards x-axis, but it is dependent on the x-coordinate. So we have to find out the force acting on the dipole. So the force acting on the dipole we know is the P into dE by dr. We know this formula. And dE by dr is equal to minus C by x square into minus C by x square. And let us take it as dx. This negative sign shows that on moving in the direction of electric field is decreasing, and therefore force acting on the dipole F would be P, which is P I cap, into dE by dr, which is minus C by x square. So F would be equal to minus P C by x square, direction is I cap, minus I cap. This means that force acting on the dipole would be towards negative x-axis, and the correct answer would be B. Now we move on the next question. In this question, you can see that there is a conducting thick spherical shell of radius, outer radius B and inner radius A. It has been charged uniformly in such a way such that the charge density on the innermost surface is minus sigma and the charge density on the outermost surface is sigma. So let us suppose that the charge on the outermost surface is Q2 and the charge on the innermost surface is minus Q1. So we know that this charge minus Q1 can only stay on the innermost surface only if there is a equal and opposite charge placed at the center of the cavity, because this charge is uniformly distributed. So I can say that a equal and opposite charge would be placed at the center of the cavity. Now we can easily find out the value of Q2. So Q2 would be 4 pi b square into sigma, and Q1 will be 4 pi a square into sigma. Okay, so this is the Q1 and Q2. Now let us see that the electric field at any point outside the shell only depends on the free charge on the outermost surface of the shell. And the charge on the outermost surface of the shell is only Q2. So the electric field at this point E out would be equal to KQ2 by R square. Now value of K is 1 upon 4 pi epsilon naught and Q2 is equal to 4 pi b square sigma and divided by r square. Cancelling this 4 pi with 4 pi. So electric field would be b square sigma by epsilon naught r square. So the correct answer is B. And the net charge on the spherical shell is 0. This is wrong because the sum of Q1 and Q2 is not 0 because they are equal. They are not equal, and the radial at a radial distance the electric field is this one outside the shell. This is wrong, and there is a net electric charge in the cavity which is equal to this one. We know that the net electric charge inside the cavity is Q1 and Q1 is this. So option D is also incorrect. So the only correct option is B. Now let's move on the next question. In this question, you can see that there is a spherical conductor which is charged up to 450 volts, and the potential outside this conductor at a distance of 15 centimeter from the surface is 300 volts. So let us draw a spherical conductor, and its potential V is 450 volts. So KQ by R is 450. And potential outside this conductor at a distance of 15 centimeter is 300. So let us suppose that this is H. So V out is equal to KQ by R plus H, and it is equal to 300. So this R plus H upon R is equal to 3 by 2, and 1 plus H upon R is equal to 1 by 2, in fact 3 by 2, and H by R will be equal to 1 by 2, so H is equal to R by 2. Okay, this is H. And now we can see that this is H, and the first option, that the potential at 15 centimeter from the center. So at a point which is inside this solid sphere, in fact this hollow sphere or conductor, the potential will remain same as that of the surface. So option A is incorrect. Now the charge of this sphere is kq by r, and it is 450. So q from this would be 15 nanocoulomb. So B is also wrong. And electric field just outside the sphere, E, will be kq by r into r. Now we know that kq by r is 450 and r is 30. So 30 centimeter, so into 10 raised to power minus 2. So we can see that this would be equal to 1500. So this is also incorrect. And the energy is the self energy, kq square by 2r. It would be equal to 3.375 microjoules. So the correct answer would be only D. Now we move on the next question. In this question, you can see that these are 4 capacitors which are connected like this, and the battery is of 60 volts. Now if this key is closed, then the charge that will flow through this key will be. So we already know that the charge on this plate of the capacitor and the charge on this plate of the capacitor is equal and opposite, and therefore we can say that the sum of charges on these two plates is 0. So Q total is 0. But when this key is closed, then we can draw the diagram again, and this would be the diagram. And this cell would be having a potential of 60 volts. C1 is 3 microfarad, this is 3 microfarad, C2 is 6 microfarads, C3 is 4 microfarads, and C4 is 1 microfarad. Now you can see that these two are in parallel, and their parallel combination will be 12 by 7. This would be 12 by 7, and the parallel combination, in fact this parallel combination would be 7, and their parallel combination would be 7, which means that equal voltage would be developed across them. So a 30 volt voltage will be developed across both of them. So let us suppose that the charge on this plate is minus Q1 and the charge on this plate is plus Q2. So we can see that Q1 will be equal to Q is equal to CV. So C is 3 and V is 30. So it would be 90 microcoulomb, and Q2 will be equal to C is 6 and this is 30. 6 into 30 is 180 microcoulomb. And now if we see the Q total of this system, then it would be Q2 minus Q1. This is Q total. So Q total new will be Q2 minus Q1, which is 90. Q2 minus Q1 is 90, and therefore we can say that there is a positive charge of 90 coulomb on this system, which was initially 0. So obviously charge has flown from B to A, and the amount of charge flown is 90 coulombs. So the correct answer is A. Now we move on the next question. In this question, you can see that the electrical conductivity of a sample of semiconductor is found to increase when electromagnetic radiation of wavelength just shorter than 2480 nanometer is incident normally on its surface. We have to find out the band gap of semiconductor. We know that obviously this conductivity is increasing due to the fact that radiation will be producing electron hole pairs, which would be increasing the number of charge carriers, and therefore it would be increasing the conductivity. Therefore, this is the threshold wavelength which is producing the electron hole pairs. So we know that the energy band gap would be equal to hc by lambda, and h into c by lambda is 2480 into 10 raised to power minus 9. We already know the value of h and c, so this E would be 0.5 eV. Okay, so the correct answer would be option number C. Now we move on the next question. Experiencing some electric force which is ILB, F would be equal to ILB, and the impulse F dt will be I dt into LB, where I dt is the amount of charge flown, so it would be QLB, and this would be equal to change in the momentum, which is impulse. Now Q will be equal to mv by LB. Okay, now m is 0.01 kilogram, v is under root of 60, and length of the wire is 0.2, and the magnetic induction is 0.1. So it is 2 root of 15 divided by 2, so it would be root 15. So root 15 would be approximately equal to 3.84. So the correct answer would be option number D. Now we move on the next question. In this question, you can see a U-shaped wire of mass 10 grams. Now 10 grams is 10 into 10 to the power minus 3 kilogram. So M is 10 to the power minus 2 kg. Okay. Now it is free to move vertically up and down. Its length is 0.2 meters, and its two ends were immersed into the mercury and to maintain the proper electrical contact, and B, magnetic field here is given as 0.1. This wire jumps to a height of 3 meters when a charge Q is sent from this wire for a very short period of time. We have to find out this amount of charge Q. First of all, we know that the velocity of this wire which produced the jump is under root 2gh. Okay, so this is under root 2gh, and this h is 3 meters, so it is under root of 60. Okay, this is velocity, and we know that this wire is our number of protons bombarded are I T by E, where E is the charge of one proton, where E we know is 1.6 into 10 raised to power minus 19 coulomb. And the efficiency of producing the beryllium is 1000 protons per beryllium. So the number of beryllium nuclei produced are number of protons bombarded by 1000. So this N of beryllium is equal to I T by E into 1000. And we know that the activity dN by dt is equal to lambda n, and dN by dt is given as 1.8 into 10 raised to power 8 disintegrations per second, and lambda will be dN by dt upon n, where n is IT upon E into 1000. This is lambda, and half-life we know is 0.693 by lambda. So This would be approximately 2407 hours. Now we move on the next question. In this question, you can see that a target of lithium is bombarded with proton beam of current 10 to the power minus 4 ampere for 1 hour, and it produces beryllium 7, whose activity is this, and it is given that efficiency of producing beryllium is 1000 proton per beryllium nuclei. We have to find out the estimated half-life of beryllium. So we know that the current of proton beam I is 10 to the power minus 4 ampere and current is Q by T. So the total amount of proton charge bombarded will be current into time, and time is given as 1 hour. So T is 1 hour, which is 3600 seconds. Okay, so Q is this current into time, and the number of protons bombarded. In this question, you can see that there is a long straight wire and finitely long wire carrying a current of 10 ampere, and there is a rectangular metallic loop of dimensions B into C, which is kept in the same plane as that of wire. The dimensions are given as shown in the figure, and the mutual inductance of the system is needed to be calculated. So we know that what we need to do is the fact that we need to find out the flux length. So let us suppose that at a distance of x there is a area strip, area element of width dx. So the area of this element dA would be C dx, and the magnetic field linked with this element or magnetic flux will be d phi. D phi would be B dA, and d phi would be B. B would be mu naught I by 2 pi x, and dA will be C dx. So d phi would be mu naught I C by 2 pi dx by x, and integrating both the sides, phi will be equal to mu naught I C by 2 pi and ln x. Okay, now the limit of this x would be from a to b plus a. So limit of x would be from a to a plus b. So phi will be equal to mu naught I C by 2 pi ln a plus b upon a. And if we equate it with mi, then cancelling I with I, m will be equal to mu naught C by 2 pi ln a plus b by a, and by substituting the values of variables, the correct answer would be option C, 139 nano Henry. Now we move on the next question. In this question, you can see that the impedance of LCR circuit is same for two frequencies. So we have to find out the value of resonance frequency in the terms of these two frequencies. So Z, we know that Z is equal to under root of XL minus XC whole square plus R square. So if it is same for two frequencies, then it would be XL minus XC whole square plus R square is same as XC minus XL whole square plus R square. So cancelling this, we can see that XL minus XC is equal to XC minus XL. Now this is omega, this is some other value, XC dash, XL dash. So this is omega 1L minus this is 1 upon omega 1C, and this is omega 1 upon omega 2c minus omega 2l. Okay, so we can take L common and we can write omega 1 minus omega r whole square upon omega 1, and here also we can take L common and we can write omega r whole square upon omega 2 minus omega 2, and L is common. Cancelling L with L, we can write down it as omega 1 plus omega 2 is equal to omega r whole square 1 upon omega 1 plus 1 upon omega 2. So omega r whole square is equal to omega 1 omega 2. So omega r is equal to under root of omega 1 omega 2, and f resonance is under root of f1 f2. So the correct answer is C. Now we move on the next question. In this question, there is a lawn roller which is a solid cylinder of mass m and radius r. As shown in the figure, this roller is pulled with a force F which is acting on the center of the roller. Then we have to choose the correct option. So we know that as this roller will be rolling purely, its alpha would be like that and A would be like that. But torque of F about center of mass would be 0. Therefore, friction would be creating the torque required to generate necessary alpha, and therefore friction would be acting in the backward direction. So the equation will be F minus F would be equal to ma, and F into R would be equal to I alpha, where I would be mr square by 2 because this is a solid cylinder, into alpha, where alpha would be equal to A by R. So this is A by R, and cancelling R with R, F would be equal to ma by 2. Now substituting this value, F minus ma by 2 will be equal to ma, and F will be equal to 3 by 2 ma. So A will be equal to 2F by 3m. Okay, this is A, and the friction will be equal to ma by 2. So friction will be equal to F by 3. Okay. Now the coefficient of friction required is mu mg, and therefore mu is equal to F by 3 mg. So the correct option is C. Now we move on the next question. In this question, you can see that hydrogen atom is initially at rest, and it emits a photon and goes from excited state 5 to ground state. We have to find out the recoil speed of the atom. So we know that when it will emit a photon, the wavelength of the photon would be r z square into 1 by n1 square minus 1 by n2 square. And 1 by lambda will be r z is 1 and n1 is 1 minus n2 is 5. So 1 by lambda will be r into 24 by 25. And the momentum of this photon will be h by lambda, and h by lambda will be equal to r h into 24 by 25. Okay, now we know that by the conservation of law of momentum, the momentum of recoil momentum of the hydrogen atom would be same. So mn into v recoil will be equal to p, and v recoil will be p by mn. P is 24 by 25 RH by mn, where R is Rydberg's constant and H is Planck's constant. So by substituting the values, we will get the velocity as 4.2 meters per second. So the correct answer would be A. Now we move on the next question. In this question, you can see that two nuclei A and B are isotopes. Now isotopes are those which has same Z but different A. Okay, these are isotopes. And isobars are those which have same Z, in fact same A but different Z. So B and C are isobars, so the mass number of B and C would be same, and the mass number of atomic number of B and C would be different. So what we can conclude about these three, that the nucleides A, B and C must belong to the same element. It is not possible. So the nucleides A, B and C may belong to the same element. Obviously it is not possible. And it is possible that A may change into B through a radioactive decay process. So you can see that A and B have same number of Z and different A1, A2. Now in any radioactive decay process, let's suppose it is alpha decay. So in alpha decay we can see that Z will change, so it is not possible. In beta decay also Z will change, and in gamma decay none of these changes. So we can say that A would not be decaying into B, and we are not considering the multiple radioactive decays, because it is written that through a radioactive decay process, yani single radioactive decay process. So C is also wrong, and it is possible that B may change into C through a radioactive decay process. So if we are talking about B changing into C, then obviously it can change by any alpha decay or beta decay. So D can occur. D is possible. Now we move on the next question. In this question, you can see that the heavy stable nuclei have more number of neutrons as compared to protons. This is due to the fact that the neutrons are heavier than protons. The electrostatic repulsive force between the protons are repulsive. We know that heavy nuclei is unstable due to the fact that proton-proton electrostatic repulsion makes it unstable. So more number of neutrons and less number of protons will lead to the greater nuclear attractive force as compared to the repulsive electrostatic force, making the nucleus stable. So the correct answer will be option B only. And we know that the nuclear forces between neutron and proton is equal. In fact, the nuclear force between proton and neutron is same, and neutron is also same. Okay, now we move on the next question. In this question, you can see that the numerical aperture of an optical fiber is the measure of. We know that the numerical aperture is the amount of light which it can gather. So it is the light gathering power. So the correct answer is D. Now we move on the next question. In this question, you can see that there is a equiconvex lens of radii of curvature of the two surface, which is numerically equal to 7. And the refractive index of this lens is 3/2. There is a silver dot on the rear surface of this lens, which means that a ray is reflected from this surface, and a ray which is incident parallel to the principal axis is getting reflected from the rear surface, and then again it is reflected from the front surface, and then again reflected from the and then again it falls on the rear surface and then gets focused on some point P beyond the lens. We have to find out the distance of this point P. Okay, so first of all we have to see that the equivalent power of the system would be twice the power of the mirror, because there are two reflections, and this ray passes through the complete lens three times. This is one, this is two, and this is three. So it would be thrice the power of lens. And this system is behaving like a refracting system due to the fact that rays entering from this side and leaving, the real image is being formed at this point. So this system is, in fact, I can say that the ray is finally emerging out in the second medium. So this is a refracting system. So the equivalent power of the refracting system would be positive, and the power of mirror would be negative. So this is minus 2 by fm, and the power of this lens is 1 by fl, and 1 by fl is 3 by 2 minus 1 into minus of 2 by r is 7. So fl is equal to minus 7. So this is minus 3 by 7. Okay, and fm is equal to r by 2. So r is 7, so this is 7 by 2. So 1 by f equivalent will be equal to 4 minus 4 by 7 minus 3 by 7. So this is minus 1. So f equivalent is also minus 1. So we can see that this system is behaving like a concave lens of focal length minus 1, and therefore the ray which is coming parallel to the principal axis will finally get focused at this point, focus before the lens. So it would be 1 centimeter before the lens. So the correct answer is A. Now we move on the next question. And after reflection, we know that these rays will go parallel to the principal axis, and hence we can say that the reflected wavefront would be plane wavefront, which would be perpendicular to the reflected beam. So the correct answer would be option number D. Now we move on the next question. In this question, there is a concave mirror whose focus is having an object and a spherical wavefront is emerging out from this object like that. These two equal parts are now arranged as shown in the figure, and they are separated by a distance of f. Now there is an object AB which is kept at a distance of f from this first one, and its position is x is equal to 0. If the position of this lens is x is equal to f, the position of this lens is x is equal to 2f, the position of this point is 3f, and this point is 4f. So we have to find out the value of x at which the image would not be formed. Okay, so we know that for this lens, this object is kept at focus, so image will be formed at infinity. Okay, now we know that for this lens, this object is kept at a distance of 2f, so its image would be from this lens, it would be from 2f, and the coordinates of that point would be 4f. And the ray which would pass through this lens are going to infinity, and when it would pass from this lens, they would form the image at the focus. So at 3f also one image would be formed, but now no image would be formed at 2f. So the correct answer of this question would be option A. Now we move on the next question. In this question, there is a equiconvex lens of focal length f, and it is being subdivided into two equal parts along the diameters. In this question, you can see that during the process of annihilation of a stationary electron of mass m0 and a stationary positron of equal mass, a radiation is emitted. We have to find out the wavelength of that radiation. So we know that annihilation process is the interaction of electron and positron, and by their interaction 2 photons or more photons are emitted. So let us suppose that only 2 photons are emitted, and in this case the energy of both of them is 2m0 c square, and energy of 2 photons is 2hc by lambda. So we need to find out lambda. So lambda is equal to h by m0 c. So the correct answer is A. Now we move on the next question. In this question, you can see that there is a concavo-convex lens. This is a concavo-convex lens, and the radius of curvature of the two sides of this lens is, this is R2, it is 40, and this is R1, this is 20. The refractive index of this lens is 3 by 2, and we have to find out the distance of an object which so that the image is formed at object itself, and we have also silvered the convex part of this convex surface of this lens. We know that for a polished lens the equivalent focal length formula is 1 by fm minus 2 by fl. Now we know that 1 by fl is equal to 3 by 2 minus 1 into minus 1 by 40 plus 1 by 20. Okay, so this 1 by fl is 1 by 2 into 1 by 40. So 1 by fl is equal to 1 by 80. And this mirror, the mirror which is formed due to polishing the convex surface, is a concave mirror, and hence the focal length of this concave mirror is minus of r by 2, which is 10. So we can say that 1 upon f equivalent will be equal to minus 1 upon 10 and minus 2 upon 80. So this is minus 1 upon 10 minus 1 upon 40. So this f equivalent will be equal to minus of 8. Now minus 8 is means that this system is behaving like a concave mirror of focal length 8, and we know that for a concave mirror, if we wish to retrace the rays back, and if we wish that object and image must coincide with each other, then we know that we should keep the object at the center of curvature of the mirror. So the center of curvature is at a distance of r, which is 2f. So the answer would be 16. So x would be equal to 16, and therefore the correct option is C. Now we move on the next question. In this question, you can see that a direct vision spectroscope is being designed to obtain the dispersion without deviation, and to achieve this dispersion without deviation condition, they used the alternate inverted prism of crown glass and flint glass. The refracting angle or the angle of prism of flint glass is 3 degree, and the refracting angle of crown glass we have to find out. We know that the net deviation is 0, therefore del 1 plus del 2 is 0, and hence we can say that a1 into mu 1 minus 1 plus a2 into mu 2 minus 1 is 0. So a1 into mu 1 minus 1 is equal to, there is a negative sign due to the fact that they are inverted prism, therefore we are not using that negative sign because angle of prism cannot be negative. So just ignore that negative sign, and a1 is the angle of prism of crown glass, so it is AC, and mu is root 2 for the crown glass, and for the flint glass A2 is 3 and mu2 is root 3 minus 1. So AC will be equal to 3 into root 3 minus 1 upon root 2 minus 1. So this will be approximately 5.3 degree. So the correct answer is C. Now we move on the next question. In this question, you can see that the continuous and characteristic X-rays are produced when electron beam is accelerated by a high potential difference of V, let's suppose V, and is made to hit on a metallic target such as molybdenum in a modern Coolidge ray tube. And lambda minimum is the smallest wavelength of the continuous X-rays, and lambda L alpha be the maximum wavelength of the characteristic X-rays. So in the all four options we can see that the relation of lambda alpha, lambda L alpha and lambda minimum is given with the accelerated potential, and we know that only lambda minimum depends on the accelerated potential. So obviously we know the relation that lambda minimum is equal to h upon EV, where this is hc upon EV. So this relation we know that this is inversely proportional relation between lambda minimum and V. So the correct answer will be option D. Now we move on the next question. In this question, you can see that while performing an experiment of determining the focal length of a concave mirror by UV method, a student recorded the given sets of position of object and image on the optical bench, which are this values, and she used the optical bench of length 1.5 meter, and the mirror was fixed at 90 meter mark on the bench, and obviously the focal length of the mirror is given as 24 centimeter. So this is 90 meter mark, and this is, let's suppose x is equal to 0. So this would be focus, so it would be 24, and hence the value of x is 66 at this point. And at this point, center of curvature would be at a distance of x is equal to 48, in fact 42. Okay, because 42 plus 48 would be equal to 90. So you can see that this is 18 and 54. So 18 means that the object is at this point, and 54 means that the object is between C and F. So it is absolutely correct, because when for concave mirror, when object is between minus infinity and center of curvature, then image is between C and F. So we have to pick the position which cannot occur. Okay, so this is 30 and 50. So this is also possible, because if u is 30, then it is again between minus infinity and C, and then v will be 50, which is between C and F, which is possible. And again similar way, 48 and 34 is also possible. But this value, which is 78 and 98 means beyond this mirror. And in this experiment, the image is obtained on a screen, obviously. And if the image is beyond the mirror, then it would be virtual, and virtual image cannot be obtained on the screen. So the reading which is not possible is option D. Now we move on the next question. In this question, you can see that there is a parallel beam of light of power 6 milliwatt, and its wavelength is 200 nanometer. The area of cross section of this beam is 1 into 10 raised to power minus 6 meter square, and it is falling normally on a metallic surface. It is completely reflected back, and we have to find out the radiation pressure. So we know that the radiation pressure is equal to 2I by C in the case when the incident radiations are incident normally on the surface and they are 100% reflected back. So in that case the radiation pressure is 2I by C, where I is the intensity of the beam. So this pressure will be equal to 2 into intensity is power upon area, so intensity would be this one, and divided by C. C is 3 into 10 raised to power 8. So you can see that it would be 4 into 10 raised to power minus 5 pascals. Now we move on the next question. In this question, it is a graph between the force and the displacement of a particle which is moving on x-axis. The mass of the particle is m, and it is given that the potential energy is 0 at x is equal to 0. So we can see that we know that du is equal to minus of f dot dr, which means that the area of fx graph represents the negative change of potential energy. And it is given in the question that potential energy is initially 0 at x is equal to 0. So we can say that it would again be 0 at that position at which the net area of the graph will become 0. Hence we can say that at x is equal to 3, the area of graph is obviously not 0, and therefore the option number 1, which says that potential energy will be 0 again at 3 and 6, is wrong. Now we have to check the function of potential energy for x is equal to 2 to 4. So we can see that for x is equal to 2 to 4, f is a function of linear function of x, and f is equal to minus of 4, which is the slope of this graph. This is 4 upon 1, and negative sign indicates that line is going down. X plus c, and at x is equal to 3, you can see force is equal to 0. So you can see that the value of c will be equal to 12. So the function of force F will be equal to minus 4x plus 12. Now if we find out du, which is u integration, it is minus of f dot dx, and integrating this, it would be 2x square minus 12x plus c, and at x is equal to, you can see that c will not be 0. You can obviously check that the value of potential energy at x is equal to 3. So the area of graph at till x is equal to 3, this area will be equal to, you can see that this is 2 and this is 4. So it is 8, and this area would be half 4 into 1. So this is 2. So area of this graph is 10, and therefore at x is equal to 3, the potential energy will be minus 10, because the area of fx graph represents the negative change of potential energy. So at x is equal to 3, potential energy is equal to minus 10. So this is minus 10, and it is equal to 2 into 9 minus 36 plus c. So c will be equal to minus 10 minus 18 plus 36. So you can see that c is equal to, this is 28, and c is equal to plus 8. So this option is incorrect. Okay. Now let us check the option C. So for 4 to 6, this is 4 in fact. This is not perfectly calibrated scale. So this is 4. So for 4 to 6, you can see that this line is going in the upward direction. So let us see that if this line is going in the upward direction, then obviously this is 4. So the function of f would be having a positive slope, and the slope of this function would be 2, so plus 2x plus c, and at x is equal to 6, f is 0, so 0 is equal to, this is 12 plus c is equal to minus 12, so f is equal to 2x minus 12. Now if I integrate this function, then u will be equal to minus of f dot dr, so this is 2x minus 12 into dx, so it would be minus x square plus 12x and plus c. Now you can see that at x is equal to 6 till this point, now we have already calculated that potential energy, the area of this graph is 10 and area of this graph is half 3 into 4. So this is 6. So the net area is 4, and obviously the potential energy initially was 0 and the net area is 4. So the net potential energy will be minus 4. So at x is equal to 6, u will be minus 4. So this is u. So minus 4 will be equal to minus of 36 plus this is 12 into 6. It is equal to 72. Okay, and plus c. So you can see that c is equal to this is minus 40. So u will be equal to minus x square plus 12x plus, in fact, minus 40. Okay, so C option is correct, and obviously we have already discussed that till 3 this area is 10, and initially the potential energy was 0, and the positive area of force and x graph represents the negative change of potential energy. So D is also correct. Now we move on the next question. In this question you can see that there is a deuterium, which is deuteron, which is moving with the speed of v. It collides elastically with another particle, which is alpha particle of mass 2m, which is at rest. After collision, alpha particle moves at an angle of theta like that with v alpha, and deuterium moves like that with vd. So we know that mv is equal to 2mv alpha cos theta. We are balancing the momentum in x-axis. So v alpha is equal to v by 2 cos theta. As well as we can say that on LOI E is 1. So on LOI the relative velocity after the collision, this angle is 90 minus theta. So another equation which we can form is v alpha by balancing the momentum in y. So initial momentum in y was 0, and therefore final will be 0. So mvd minus 2mv alpha sine theta. So cancelling m with m, vd is equal to 2v alpha sine theta. Okay, this is vd, and E is 1. So E is V relative along LOI. So along LOI, V relative is V alpha minus VD sine alpha sine theta divided by the, this is plus because we have to take the relative velocity, divided by the initial velocity along the LOI, which is V cos theta. This is 1. So V alpha is V upon 2 cos theta plus Vd is 2V sine theta. So this is 2V alpha, where V alpha is V by 2 cos theta. This is V by 2 cos theta into sine square theta, and it is equal to V cos theta. So cancelling this 2 with 2, you can see that V sine, you can write it down like this, that V is common, and this is 1 by 2 cos theta. In fact, you can take out cos theta also. So this is v by cos theta. This is 1 by 2 plus sine square theta, and it is equal to v cos theta. So 1 by 2 plus sine square theta is equal to cos square theta, and 1 by 2 is equal to cos 2 theta. So 2 theta is equal to 60 degree, and therefore theta is equal to 30 degree, and therefore we can say that theta is 30. V alpha is v by root 3, where v alpha is this one. So v alpha is v by 2 cos 30. So this is v by root 3. So option B is also correct. Vd is v by root 3, where Vd is this one, 2v alpha sine theta. So Vd is 2v alpha sine theta. So this is 2 into v by root 3 into sine 30 is 1 by 2. So this is again v by root 3. And the fraction of 2/3 energy of deuteron is transferred to alpha particle. So kinetic energy of alpha particle is half into 2m into v alpha square. So this is mv square by 3, and kinetic energy of deuteron is half mv square. So you can see that 2/3 kinetic energy is transferred to the alpha particle. Okay, so the correct answer is A, B, C, D. Now we move on the next question. In this question you can see that there is a deuteron which is moving with the speed of v, collides with the alpha particle which is at rest, and it is deflected by 90 degree, like that. So obviously alpha particle would be deflected at some angle theta. Okay, and its speed is vd after deflection, and the speed of alpha particle is v alpha. So we know that mv is equal to 2mv alpha cos theta. Okay, this we know, and v alpha will be equal to v by 2 cos theta. Now this would be the LOI, line of impact, and this angle would be theta. So on LOI E is 1 because elastic collision is occurring. So v alpha upon v cos theta is equal to 1. So we can say that v alpha is equal to v cos theta. So this is v cos theta is equal to v upon 2 cos theta. So cancelling this v with v, cos square theta is 1 by 2 and cos theta is 1 by root 2. Okay, so theta would be equal to 45 degree. So theta is 45, and v alpha is equal to, this is v alpha is v by root 2, and vd is we can find out the vd. So in this question you can see that there are two progressive waves, this and this, traveling in opposite directions. They superimpose on each other and we have to choose the correct option. We know that the resultant wave would be, we know that sine A plus sine B is equal to 2 sine A plus B by 2 cos A minus B by 2. And therefore we can say that it would be, resultant wave would be 5 into 10 raised to power minus 3 sine 30x cos 420t. Therefore this is incorrect, this is incorrect. and at x is equal to 0.262 meters, we can say that the amplitude as a function of x is 5 into 10 raised to power minus 3 sine 30x. So 5 into 10 raised to power minus 3 sine 30 into 0.262 is approximately equal to, this is approximately 1 odd multiple of pi by 2. So we can say that this would be 1. So this is 5 into 10 raised to power minus 3. So this is a antinode. So option C is correct answer. I've already concluded it with the calculator, because obviously we have to use calculator in these kind of questions, or you will take so much of time. And in this D part, the amplitude of the oscillation of the particle is this one, the particle which is situated at 0.17. So A at 0.17 would be equal to 5 into 10 raised to power minus 3 sine 5.1, because 30 into 0.17 is 5.1. So it would be approximately 4.63 mm. So correct answer is D. So the correct answers are C and D. Now we move on the next question. In this question, you can see that 2 moles of nitrogen are filled in a container, and the container has negligible thermal capacity. These 2 moles are initially at 17 degrees Celsius, and this gas is compressed adiabatically from initial volume of 120 liter to the final volume of 80 liter. We have to find out the correct option. So let us see that the initial temperature was, this is 290 Kelvin, and the initial volume was 0.12 meter cube in standard unit. Okay, and the initial pressure is nRT initial by V initial. So by substituting the values of these, n is 2, so the initial pressure would be 40.2 kilopascals, which is option A. And we know that T1 V1 to the power gamma minus 1 is equal to T2 V to the power gamma minus 1. So T1 was 290 and V1 was 80. You can use the unit liter in this equation, as the multiplication factor of conversion would be cancelled out on both the sides. So gamma is obviously diatomic gas, so gamma is 5 by 2, in fact 7 by 2. In fact, I think gamma is 1 plus 2 by F, and F we know is 5, so gamma is 7 by 5. So this is 7 by 5 minus 1, which is 2 by 5, and T2 and V2, in fact V1 was 120 and T2 and V2 was 80. So this is 2 by 5. So T2 would be equal to 68 degrees Celsius approximately. This is a quite tough calculation. You have to calculate it with some time. So it would be around 68 degrees Celsius. And the work done, obviously in this compression, work done would be negative, so this option is incorrect. And delta U would be NCV dt. Okay, and N is 2, CV is F by 2R, so F is 5, so this is 5 by 2. R and dt is 68 minus 17. So 68 minus 17 would be equal to 51 degrees Celsius. Okay, so this would be 5 into R, which is 8.314, and this delta T can be used in any unit. So this is 51 only. So this is approximately 2.12 kilojoules, and internal energy of the gas will increase obviously because temperature is increasing. So the correct answers are A and D. Now we move on the next question. In this question, you can see that there is a dipole. Here is a dipole which is placed on this x-axis like that. Okay, and there is a point P. In fact, there is a point x comma y where we have to find out electric field and the potential. So we know that if this angle is, let's suppose, theta, so this component of dipole moment would be P cos theta and this would be P sin theta, and the electric field along this axis would be E1 and perpendicular to this axis would be E2 in this direction. E1, so first of all, cos theta is equal to x upon r, sin theta is equal to y upon r. E1 will be equal to 2 kp cos theta by r cube, and E2 would be equal to kp sin theta by r cube. Okay, and the x component of electric field, this is Ex, this is angle would be theta and this angle would be theta. So Ex would be equal to E1 cos theta minus E2 sin theta. So Ex would be equal to E1 is 2 kp by r cube cos square theta minus kp by r cube sin square theta. So this is kp by r cube, and 2 cos square theta would be 2x square minus y square divided by r square. So the correct answer is A. And Ey would be E1 sin theta. You can see that the component of E1 along y is E1 sin theta plus E2 cos theta. So this would be 2 kp sin theta cos theta by r cube plus this would be kp by r cube into this is sin theta cos theta. So it would be 3 kp by r ki power 5 and sin theta cos theta would be xy. So the correct option would be C, and we know that the potential is P dot R upon 4 pi epsilon naught r cube. You can open this formula and you would be getting P dot R equal to P into R into cos theta, and cancelling R with R cube. So the correct answer would be D. Now we move on the next question. In this question, you can see that there are two equal positive charges which are placed at these 2 points. This is Q and this is 0 comma A, and this is also Q, positive Q, and this is also 0 comma minus A. And there is a point, this point at a distance of x. This is phi, this is phi. We have to find out the net electric field at this point. So we can see that electric field due to this charge is E like that, due to this one is E like that, and net would be in this direction. So E would be equal to KQ, this is R, so KQ by R square, and E net would be equal to 2E cos phi. So E net would be equal to 2KQ by R square into cos phi, where cos phi is x upon R. So x upon R. So E net would be equal to 2KQ x upon R cube, and this is 2KQ x upon x square plus a square to the power 3 by 2. So this is a wrong option because there is a in the numerator and it should be x. So the next option is for the larger value of x, electric field is proportional to 1 upon x square. So obviously if x is very greater than a, then we can neglect this a, and this would be x cube, and cancelling x with x cube there would be x square. So this is correct, and E would be maximum for this one. So let us check it out, and we have already done it in the previous section, so let us again check it out, that dE by dx. So dE by dx is 2KQ, and this is let us do it on the next page. E is equal to 2KQ x upon x square plus a square to the power 3 by 2, and dE by dx will be equal to 2KQ and x square plus a square to the power 3 by 2 into x into, in fact, 1 minus x into 3 by 2 into x square plus a square to the power 1 by 2 into 2x divided by x square plus a square ka cube. So equating it to 0, so we can see that x square plus a square to the power 3 by 2 is equal to 3x square into x square plus a square to the power 1 by 2. So you can see that x square plus a square is equal to 3x square, and 2x square is equal to a square, and x will be equal to plus minus a by root 2. So obviously this option is also correct, and this is wrong, because if C is correct then automatically D is wrong. Now we move on the next question, and therefore the change in flux would be B into S into L divided by R. Now B L by R and S we know as V naught M R by B square L square. So cancelling this BL with BL and R with R, so this is M V naught by BL. So the correct answer is D. So the correct answers are B and D. Now we move on the next question. In this question you can see that these are two parallel rails. These are connected by a resistance R, and there is a rod placed on these two rails. The length of the rod is L, and the magnetic field in this plane is inside the plane B. We have given a velocity v naught to this rod, and we have to find out the following correct options. So first of all, let us see that this rod will be, let us draw this one, a force of magnetic force will be acting on this rod in the backward direction, because due to the motion of the rod, EMF is generated in the rod and the current would be flowing like that. Okay, and therefore a force will be developed in the rod in the backward direction, which would be retarding the rod. So we can write down that this F is equal to ILB, and I will be equal to BLV by R. So this would be B square L square V by R. So this F is obviously retarding force, so we can write it down as minus dV by dt, and this is M. So dV upon b square, or we can just write it down as v, is equal to minus m, in fact minus b square L square by mr dt, integrating both the sides. Limit would be from v0 to v and from 0 to t. So by putting the limit, this is ln v by v0, and it is equal to minus of e to the power, in fact minus of b square L square by mr into t, and v is equal to v0 e to the power minus b square L square t by mr. So this option is incorrect, obviously, because this is b into L only. And option B, that rod stops after traveling a distance of x. So to check this option, we can easily see that f is also equal to a m dv by dx. So f is b square L square v by mr, and this is a, so a will be v dv by dx. So you can see that by integrating this equation, v will be equal to b square L square by mrs, where s is the distance traveled by the rod before coming to rest. So s will be equal to v0 mr by b square L square. This is s. So correct answer will be B option. And the total energy dissipated in the resistance is this one, the 1 by 4 m v0 square. This is wrong, because obviously there is no other place where energy would go. If the rod was moving with the initial kinetic energy of half m v0 square and finally it came to rest, then the loss of kinetic energy would definitely be lost as heat, in form of heat in the resistance. So the heat loss in the resistance would be exactly equal to half m v0 square. Therefore we can say that this option C is incorrect. Now the total charge that flows in the circuit is this one. So you might be thinking that we should go like that we have made this equation of velocity as a function of time, then we should find out the current as a function of time, then we should integrate it. In fact, I have a smaller method to find out this charge. We already have studied in the electromagnetic induction that in these cases the charge flown through the circuit is change in flux delta phi by r. Now you can see that if the rod has moved by a distance of s, then the area, change in area, will be s into L. In this question, you can see that an electromagnetic wave is represented by its magnetic field, which is given by this equation, and the direction of magnetic field is along j cap, which is y-axis. Now we have to choose the correct alternative. So first thing which is being asked, that the wavelength and the frequency of the wave. So we know that 2 pi by lambda is k, and in this case k is pi by 2 into 10 raised to power 3. So lambda is equal to 4 into 10 raised to power minus 3. So lambda is 4 mm. First of all, this is lambda. Now frequency is 2 pi f, and it is equal to 3 by 2 into pi into 10 raised to power 11. So f is equal to 3 by 4 into 10 raised to power 11. So 3 by 4 is 0.75 into 10 raised to power 11. And you can see that f would be equal to, this is 75 into 10 raised to power 9. Okay, so this is 75 gigahertz. So option A is correct. The energy density is half B naught square by mu naught, and this is average energy density. So this is half into B naught is 2 into 10 raised to power minus 5 whole square by mu naught is 4 pi into 10 raised to power minus 7. So this is approximately 159 microjoules per meter cube. So it is not correct. The electric field vector would be in k cap plus k cap, because the propagation direction is in minus x axis and magnetic field is in y axis. And you can also check the value of E, which would be E naught, which would be the 6000. You can check that E naught by B naught is equal to C. Okay, so the correct answers are A and D only. Now we move on the next question. In this question you can see that in this circuit the current flowing through this 8 ohm resistance, this one, is equal to 1 by 2 amperes, 0.5 ampere. Okay, and the internal resistance of this cell is equal to 0.8 ohms. This emitter is ideal. Okay, so we have to find out the correct options. We know that this is 8 and this is 2, 8 and 2. So this is 12 ohm and this is 6 ohm. And 12 and 6 ohms are in parallel. So the equivalent combination of this one is 4 ohms. The parallel combination of 12 and 6 is 4 ohm. So this is 2, 4 and 2. This is 8 and this is 12. So we can first of all say that if 0.5 ampere is going through this resistance, then this is completely 12. So the current flowing through this resistance would be 1 ampere. And therefore the total current from this would be 3 by 2 ampere. And this is 2 and this is 4 and this is 2. So it is 8. And the current flowing through this one will be 1 ampere. You can find out. And therefore the total current from this is 5 by 2 ampere. Okay. So the reading of this emitter will be equal to, this is 3 by 2 ampere. So this is correct. The potential difference between A and H. So you can apply KVL in open loop AC, E, G, H. So this is VA minus 2 into 5 by 2 minus 3 by 2 into 2 minus 1 by 2 into 2. In fact 1 by 2 into this is 10 is equal to VH. So VA minus VH will be equal to, this is 5 plus 3 plus 5. This is 13. The potential difference across C and F is 9 volts. So the potential difference across C and F is can be calculated by applying KVL in this loop. So this is VC minus 3 by 2 into 2 minus 1 into 6 is equal to VF. So VC minus VF is equal to 9. And the EMF of the cell is 24 volt, which we can find out by the fact that the potential difference across A and B, VA minus VB, is minus 5, minus 12 and minus this is 5 by 2 into 5. So it is 22 volts. You can again apply KVL in this loop and you can find out. And this is equal to E minus IR, where I is 5 by 2 and R is 0.8. So E will be equal to, this is 24 volts. So the correct options are A, B, C, D. Now we move on the next question. In this question, you can see that this is an experiment of producing two coherent sources with multiple reflections from a transparent plate. The refractive index of plate is 1.54, and these rays after reflection are going to point P and to point Q. So it is given that the path difference between these two rays at P and at Q is same, which is 5000 nanometer, and we have to find out that out of which wavelength from the given wavelengths the wavelength would produce constructive interference at these 2 points. Okay, so we have to pick the wavelength which would produce the constructive interference as at these 2 points. You first of all can see that these two waves are reflected from this point, and this point, and each of this point reflection is a reflection from free end, because ray is going from denser to rarer medium in this reflection. Again in this reflection it is going from denser to rarer, and again in this reflection it is going from denser to rarer. So in any of these reflections there would be no phase change, and therefore we can say that the constructive interference condition would be delta x is equal to n lambda for constructive interference. So delta x is given as 5000 nanometers, and n is some integer, and lambda is let us suppose this is lambda, so it is 416.67. So n will be equal to 12 in this case. So this is the correct answer because it is an integer, and 5000 divided by 555.56, in this case n would be equal to 9, and therefore it is a correct answer. And 5000 divided by 625, in this case n would be equal to 8. So this is the correct answer, and this would be 5000 divided by 666.7 is approximately 7.5, which is not correct answer because odd multiple is not allowed for maxima. This n should be integer. So the correct answers are A, B and C. Now we move on the next question. In this question, you can see that there are two identical transparent cylinders like this. Each cylinder has a radius of 10 centimeter and a refractive index of root 3 in fact. They lie parallel to each other such that their axes are parallel to each other, and they lie on a horizontal mirror like that, and these are separated by a distance of 10, in fact x. This is x. Now there is a ray which is coming horizontally and it is incident on this cylinder at a height of h from the plane mirror, and this ray is emerging out from the cylinder at this point, from this point. This point has a height of h1, which is 0.1 meter, and 0.1 meter is obviously 10 centimeter from the mirror. So this is the radius, so it would emerge from this point. It goes on a plane mirror and it gets reflected from the plane mirror, and again it gets incident on this cylinder. I have drawn the symmetrical diagram because it is given that when light is incident after these two refractions from the cylinder, then it exactly moves on the same initial line and at the same angle. So this could only happen if this figure is exactly symmetric. So you can see that if this angle is r, angle of refraction, this would also be r. Okay, because this is radius, and therefore this is the exterior angle, so it would be 2r, and this is also 2r. Okay, so this is also 2r due to the fact that the ray is coming from air and it is finally emerging out in air, so the angle of incidence would be same. this would be 90 minus 2r. Let us suppose that it is I. So I would be equal to 90 minus 2r, and this would again be 2r, and this would be r, and this would be r, and this would be 2r, and this would be 2r. Okay, so now first of all let us see that 2r, in fact we are applying the Snell's law in this refraction, so we can say that 1 sine 2r is equal to root 3 sine r. And you can write sine 2r as 2 sine r cos r is equal to root 3 sine r. So cos r is equal to root 3 by 2. So r is equal to 30 degree. This is r. Okay, if r is 30 degree, then we can easily find out the value of x. So let us suppose that this is x naught and this is x naught. Okay, and this is obviously r and this is obviously r. So x is equal to 2x naught plus 2r. Now you can see that tan I, this is tan I, and tan I is equal to x naught upon this height. This height is 10 centimeter, 0.1, and I will be, this I will be equal to 90 minus 2r, so it would be 30 degree. So tan 30 is 1 by root 3, so x naught would be equal to 10 by root 3. So x will be equal to 20 by root 3 plus 20, which is approximately 31.54. Now the angle of incidence on the plane mirror in the midway of the two cylinders is 30 degree. This is also correct. We have already derived it. And the ray enters the other cylinder at a height of 0.1. This is also correct. And now we need to find out the value of h. So the value of h, you can see, will be equal to, this h will be equal to this r plus r sine 2r. So h will be equal to r plus r sine 2r. So h will be equal to 10 plus 10 sine 2r, which is 60. So h will be equal to 10 plus 10 root 3 by 2, which is approximately 8.7. So the correct answers of this question are A, B, C, D. Now we move on the next question. In this question, you can see that there is a diode, and in the working of a PN junction diode, the diffusion current dominates when the junction is in forward bias. This is correct one. We know that. And drift current dominates when the junction is in reverse biasing. This is also correct. Depletion region width increases with the increase in forward, decreases with the increase in forward biased voltage. This is also correct. And the electric field in depletion region depends on the number of ionized dopants rather than the dopant density. This is wrong, because obviously electric field developed in the depletion region depends on the density of the dopant, because more would be the density of the dopant, and smaller would be the depletion layer, and a smaller depletion layer would result in larger amount of electric field in the depletion region. So the correct answer is ABC. So this was the complete solution of NSEP 2023, and I've attached the answer key, as I've already stated, at the end of this paper. So now you can just scroll to the answer key. So this is the answer key.